Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening. So today we're going to start the next chapter, congruent triangles. All right. So the term congruent or congruency is used when two things are identical. When two things are identical in every aspect. So now talking in terms of mathematics, when two polygons are identical, then they're said to be congruent to each other. So if the two polygons are triangles, when we talk about two triangles are said to be congruent to each other. If they are identical, that is, one looks just like the other. If you place, one triangle over the other one, you rotate it and you place it in such a way that they coincide. One triangle superimposes the other triangle. That is, when you place one over the other in a particular way, the triangle below is covered completely. So then the two triangles are said to be identical or congruent to each other. So congruency simply means identical, congruent, identical. When one triangle looks exactly like the other in every aspect, sides are equal, angles are equal, then the two triangles are said to be congruent to one another because they are identical. So two pentagons are congruent to each other if their corresponding, they have 5 sides. If their corresponding sides are equal and their corresponding angles, there are 5 interior angles and 5 sides. If the corresponding interior angles are equal and the corresponding sides are also equal, then the two pentagons are said to be congruent to one another. That is, one is just like the other. One pentagon is just like the other one. They are identical pentagons. Now you can also say congruent line segments. So congruency can be extended beyond plane figures. You can say congruent line segments. Supposing you have a line segment AB, say 4 centimeters. You have another line segment PQ, a different line segment PQ, which also measures 4 centimeters. AB is equal to 4 centimeters, PQ is also 4 centimeters. That means line segment AB is congruent to line segment PQ, is congruent to, this is the symbol for congruency, is congruent to. When you simply write this, this is similar, that's different. Similarity in triangles we'll see next year. So when you just write the symbol, this means similar to, is similar to. This is congruency, is congruent to. So this symbol, how do you read the symbol? Is congruent to, is congruent to. Like you already know this. How do you read the symbol? Is equal to, is equal to. When you write this one, when you use the symbol, it's read as is equal to. See here, A is equal to 5. B is equal to 10. So this symbol is read as is equal to. Similarly, this symbol is read as is congruent to. See here, this equal to symbol and an S kind of a thing above it. Is congruent to. So line segment AB is congruent to line segment PQ. Line segment AB is congruent to line segment PQ. Why? Because AB is 4 centimeters, PQ is also 4 centimeters. They are two different line segments, but they are identical in the sense they have the same length. Now there is no other aspect of comparison in line segments. Line segments only have a definite length. Like in triangles, you can compare the 3 sides and 3 angles. Whereas in a line segment, there's only one aspect for comparing. That is the length of the line segment. There's only one aspect, and that aspect is equal. The length of AB is 4 centimeters. The length of PQ is also 4 centimeters. So we say that the line segment AB is identical to the line segment PQ, which means they're congruent to each other. Similarly, angles. Now, supposing you have an angle, let me call it ABC, angle ABC. Angle ABC, which is say 40 degrees. Okay, another angle PQR, another angle PQR, which is also 40 degrees, which is also 40 degrees. ABC, angle ABC is one angle. There is another angle PQR. They're two different angles. Now, again, when it is we have angles, there's only one aspect for comparing. That is the measure or the magnitude of the angles. The magnitude of angle ABC is 40 degrees, and the magnitude or the measure of angle PQR is also 40 degrees. So since they have the same magnitudes, angle ABC is congruent to angle PQR. Congruency simply means identical, equal in every aspect. In whatever aspects you can compare them, in every aspect they should be equal. Then they are congruent. So when we take two triangles, we know that a triangle has 6 parts. A triangle has 6 parts, 3 sides and 3 angles. 3 sides and 3 angles. So these are the 6 parts or the 6 aspects which you can compare. The 6 aspects of one triangle is compared with the 6 aspects of the other triangle. The corresponding aspects, see, you cannot compare a side and an angle. You will be comparing the corresponding, the related aspects. So a triangle has 6 parts or 6 aspects, 3 sides and 3 angles. Another triangle, 3 sides, 3 angles. So this triangle is 6 parts, the other triangle 6 parts. So you will be comparing the relevant or the corresponding 6 parts. If they are equal, then they are congruent. Is that fine, children?
Yes, ma'am.
We will be studying only, we'll be studying only congruency in triangles. There are other concepts also, congruent quadrilaterals, plane figures. One very important thing is a triangle and a quadrilateral cannot be congruent because they have different aspects. A triangle has 3 sides and 3 angles, but a quadrilateral has 4 sides and 4 angles. You cannot compare a triangle and a quadrilateral. So you cannot establish congruency between a triangle and a quadrilateral or a square and a pentagon, a decagon and a nonagon. No. So if you're comparing two plane figures, they must have the same number of sides and angles. So which means you can compare 2 squares, 2 rectangles, 2 triangles, 2 parallelograms, 2 pentagons, 2 hexagons. So you cannot compare a hexagon and and an octagon because their aspects are different. A hexagon has 6 sides and 6 angles, whereas an octagon has 8 sides. There itself, there is no match. An octagon has 8 sides and 8 angles. And when we talk about congruency, we are talking about equality of every corresponding aspect. When we are talking about congruency, we are talking about equality of every corresponding aspect. Corresponding sides must be equal, corresponding angles must be equal. But when you take a hexagon and an octagon, this one has 6 sides, the other has 8 sides. There itself, the aspects, they don't match. Then how can you say that they're identical? Because congruency is being identical, the situation of being identical. All right, so the topic is congruent triangles, which means we will be given 2 triangles, and with the help of some congruence rules we have, they're called congruence criteria. With the help of the congruence criteria, you will have to prove that the two triangles are congruent to each other. That's what we will be seeing in this chapter. You will be given two triangles and some information related to the two triangles. With the help of the information given, you must show that or prove that the two triangles are identical. The two triangles are congruent to each other. So to prove that the triangles are congruent, you need to compare all the three sides and the three angles, which is tedious. Which is tedious meaning it is time consuming. Every time you'll have to, if you have to check all the six, parts, that is the three sides and the three angles, it's time consuming. So we have something called the congruence criteria. Congruence criteria. Why do we have the congruence criteria? They help you to establish congruency between two triangles easily, meaning in less time. You don't have to compare every aspect. So when I list out the criteria to you, you will understand. So it is just congruence criteria just simplifies your job in proving that two triangles are congruent to each other. Using the congruence criteria, you can easily establish congruency, but if at all the triangles are congruent, you can easily prove that they're congruent to each other. You don't have to compare all the corresponding three sides and the corresponding three angles. It's enough if you compare three parts. Which three parts we'll see now. Yeah, if at all you want to write down something, you can take down, children. I'll just wait for a minute.
Written, ma'am.
Yeah. Yeah. Sorry, please write down, children. Children, please write down. So two triangles are said to be congruent if their corresponding sides are equal and their corresponding angles are equal. So these are the parts, the 6 parts of a triangle, 3 sides and 3 angles. So if their corresponding sides and corresponding angles are equal, then the two triangles are said to be congruent to each other. That is identical. Identical. Okay. So now to show that two triangles are congruent, to simplify, to make your task easier, we have something called the congruence criteria. We have 5 congruence criteria. So they are SSS, SSS, SAS, ASA, AAS, RHS. So SSS is side, side, side. SAS, side, angle, side. ASA, angle, side, angle. AAS, angle, angle, side. RHS, right angle, hypotenuse, side. So how do you read this? SSS congruence criterion. Criterion is singular. Criteria is plural. Criterion is singular. Criteria is plural. So congruence criteria, because 5 things, we are listing 5 things, but each of it is a criterion. Each of it is a criterion. All the 5 together, criteria, plural. Okay, so SSS congruence criterion or rule. Criterion meaning rule. Like saying rule and rules. Like saying rule and rules. Rule, rules, congruence, rules. Okay, like that. So SSS congruence rule or SSS congruence criterion. SAS congruence criterion. ASA congruence criterion, AAS congruence criterion, and RHS congruence criterion. So using any one of these 5 criteria, we will be able to show that two triangles are congruent to each other easily. Otherwise, we'll have to compare all the 6 aspects, which will take more time and you'll need more information also for that. More information also should be given for that. So with the help of these criteria and minimum information given, you will be able to check if the two triangles are congruent or not. Information given also can be minimum. And you'll be using these rules and checking if the two triangles are congruent or not. If you have to check all the 6 aspects, then more information also should be given. So with the given limited information, using these rules, you can easily check if the two triangles are congruent or not. That is identical or not. Please understand, congruency is nothing but a state of being identical. Two things are identical. That means they are congruent. Now two circles of the same radii. If you have two circles, you know, a circle with center O, a circle with, okay, circle with center A and radius 3 centimeters. A different circle with center B and radius 3 centimeters. So these are two different circles, one with center A, the other with center B. But they have the same radius 3 centimeters. So if you lift the circle with center B and place it on the circle with center A, the circle with center B will completely cover the circle with center A. That means it will be the second circle superimposes the first circle. That means the two circles are congruent to each other. They are identical. Yes, definitely they are identical because both have the same radius. They have the same radius.
Yes, ma'am.
Yeah. So two circles of different radii. So it's very clear. One is small, the other one will be big. Then how are they identical? How can you say they're identical?
They'll not be congruent, ma'am.
Yeah. So one is small, the other is big. That means they're not identical. If they're not identical, they're not congruent. Okay.
Ma'am, could you please show the previous slide?
Yeah, sure. One more thing is, so two figures. This is very important. Make a note of this. I'll show you. Two figures are said to be congruent said to be congruent if they have the same shape and size. They must have two figures are set, two figures. I'm not saying two triangles. I'm saying two figures. Two figures are said to be congruent. Two figures are said to be identical if they have the same shape. They must have the same shape. Like both must be triangles. Both must be triangular in shape. Or both of them must be quadrilaterals. Only then they'll have the same shape, right? Same shape. If you draw one circle and one triangle, they have different shapes. One circle, one triangle, they have different shapes. Forget the size, they are different shapes. If you have a pentagon and a triangle, they're two different shapes. Triangle and pentagon, they're two different shapes. So two figures are said to be congruent if they have the same shape. The shape must be the same. Both pentagons, two pentagons will have the same shape. 5 sides, 5 angles. So they must have the same shape and the size. It's not enough if they have the same shape. They must have the same shape and size. The size also should be the same. So two figures are said to be congruent if they have the same shape and size. Shape alone is not enough. And size. The sizes also must be the same. So if you pick a shirt, two shirts of the same brand, okay, two shirts of the same brand, of the same size. So they're identical. When you place the shirts, when you hold the shirts, up like, with the shoulders, you will see that they have the sleeve, whatever, all the parts of the shirt will coincide. Yes, children. Please write, I'm just coming. Give me 2 minutes, I'm coming back. And this one, children?
Ma'am,
Yes.
I have a doubt.
Yes.
Ma'am, what's the difference between ASA congruence criterion and AAS congruence criterion?
Yeah, we are still to see that. I'll explain, and once it's done, if you have any queries, you can ask me. We
Yes,
haven't
ma'am.
come to that. Yeah. Anything else, Madhumita?
No, ma'am.
All right. There's the next one. You can just, these are just, kind of notes. If you're interested, you can take up this.
Take them down, ma'am.
Yeah. So these are two circles with center. There's one circle with center A and radius 3 centimeters, another circle with center B, but same radius 3 centimeters. So the circle with center A is congruent to the circle with center B. Circle with center A is congruent to the circle with center B because they have the same radius. So two line segments are congruent if they have the same length. Two angles are congruent if they have the same magnitude. Two circles are congruent if they have the same radius. Correct?
Yes, ma'am.
Yeah. So let me write that here. So two line segments are congruent if they have the same length. Two angles are congruent if they have the same magnitude. Then I'll write here, two circles are said to be, are congruent. Two circles are congruent if they have the same radius. All right, children?
Yes, ma'am.
All of you?
Yes, ma'am.
Yes, ma'am.
All right. All right, children. Very good. Fine. So I always, get into the exercise and explain the rules with the help of the, the questions or the proofs. Because then you would understand better is my, perception. So we're getting into the chapter from NCRT. So first we'll be completing all the examples and exercise questions from NCRT. And then we'll do the extra proofs. Okay, so this is this is example 1 from NCRT. As I told you, first we'll finish everything from NCRT. We don't have inequalities that's removed from the syllabus this year alone. So we're not doing inequalities. So the first part of the chapter, congruent triangles. Okay, so see here, in the given figure, OA is equal to OB. See OA. So you can see the figure here. You can see the figure here. Okay, in this figure, OA is equal to OB. OA, where is OA? See here, this is OA. OA is equal to OB. See, it's marked also. OA is equal to OB is marked. OD is equal to OC. OD, can you see here? It's marked. OD is equal to OC. Okay, show that triangle AOD is congruent to. I told you the symbol means is congruent to. So how do we read this? Show that triangle AOD is congruent to. This alone. This one is congruent to. Show that triangle AOD is congruent to triangle BOC, and also show that AD is parallel to BC. AD is parallel to BC. How many of you have learned this chapter in school already?
Ma'am, we completed this chapter, ma'am.
Madhumita.
Ma'am, we also completed this chapter.
Okay.
And we also completed, ma'am.
Okay. What about Sindhu and Sanjay? Sindhu, Sanjay? Oh, you've just logged in and studying for some other subject, is it? I don't think you're at your desk, both of you. Okay. Ma'am, our mic is not working. All right, children. All right. Okay. So you'll have to show that these two triangles are identical, AOD and BOC. And also show that AD is parallel to BC. All right. So now, you know that when two lines intersect, vertically opposite angles are equal. When two lines intersect, vertically opposite angles are equal. Now take up the triangles AOD and BOC. Take up the triangles AOD. See, this is the triangle AOD because you'll have to show that they are congruent. Take up the triangles AOD and BOC. This is BOC. This is BOC. This one. Okay. Now we know that this side, I'll call this the first triangles and I'll call first triangle. I'll call this the second triangle. We know that this side of the first triangle is equal to this side of the second triangle. It's given. We know that this side of the first triangle is equal to this side of the second triangle. It's given. And we also know that this angle of the first triangle is equal to this angle of the second triangle. That's not given, but we know that when two lines intersect, vertically opposite angles are equal. So this angle, this is an angle of the first triangle. This is an angle of the second triangle. So these two angles are equal because they are vertically opposite angles. Now we'll observe, we'll have to identify. Now we have three equal parts. We have three equal parts. We have two pairs of equal sides and one pair of equal angles. We have in the two triangles, we have two pairs of equal sides and one pair of equal angle. So on this, we have only one congruence rule, that is SAS, because two pairs of sides and one pair of angles is only SAS. See it, you can check. See it. Two pairs of sides and one pair of angles. SAS. SAS. Only that we have. So now, see here, when I say two pairs of equal sides here, one pair is OA is equal to OB. The other pair is OD is equal to OC. Two pairs of equal sides we have. And we have one pair of equal angles. So relevant to this, the congruence rule is only SAS. Now, what is this SAS? SAS is two sides. When we say two sides, that means we are comparing two pairs here. When you take up one triangle, when you say SAS, that means two sides and the included angle. SAS, two sides and the included angle. Now see here, check with the first triangle. Check with the first triangle. You have used the information about this side. That is while listing the equalities. While listing the equalities, we have used the information regarding this side, and this angle. See here, two sides and the included angle. Why is this the included angle? Because these two sides are the arms of that angle. We say included angle because the two sides are the arms of that angle. See here, when you're talking about this angle, an angle has two arms. We know that an angle has two arms. Now, which are the two arms of this angle? This one and this one. Those two sides are the arms of this angle. That's why this is called the included angle. This is called the included angle. Two sides and the included angle. Why included angle? Because these two sides are the arms of this angle. So now why are we taking these two sides? Why are we not taking this side? Because we have not written anything about this side. Like while listing the equalities, we have not mentioned anything about that side. We have mentioned about this side, and this angle. So two sides include angle. And here also in this triangle, we have mentioned about this side, and this angle. Two sides include angle. See here, this is the angle. So these are the arms of the angle. These are the arms of the angle. So we say two sides include angle. So by S, see, so see here, this minimum information, we don't know the length of AD and C here. Now we are just going to show, we are just about to say that the two triangles are congruent to each other. But do you know anything about AD and BC? No, we don't know. We don't know if AD and BC are equal. We don't know if AD and BC are equal. What about the other angles? These angles, this angle and this angle, this angle, this angle. That is the remaining angles of the triangles. We don't know if they're equal. No information is given. So with this minimum information and using the congruence criterion, we are able to show that they are congruent. They will be congruent. They will be identical. They will be identical. If they're identical, now once you prove that they're identical, their remaining corresponding parts also will be equal. Once you say that they're identical, what will happen? Now with this minimum information, we say that the two triangles are congruent. That means they're identical. If they're identical, the remaining things which you didn't know, the remaining corresponding parts also will be equal. Because now they're congruent, they're identical. That means the other things which you did not know. Now, like for example, the third pair of side is AD and CB. The third pair of side is AD and BC. We don't know about AD and BC. We don't know if they're equal. But now because the triangles are congruent, AD will be definitely equal to BC. Okay, let's finish this. Let's finish this. See here, children, this is how you have to present the proof. This is till here is the given question. So you'll have to write what is given. Okay, you should give the subheading kind of given and write what is given. What is given? These two. So write that. That is to be written against given. Then to prove, or you can write to prove that, to prove or to prove that, whatever. Sometimes we use the short form TPT. To prove that, TPT. Or you can write to prove like this. What you have to prove? You'll have to prove that this one. Or you can write to show that also. To show that, TST, to show that, whatever. What you have to prove? This one and this one. So write it here. See, to prove that these two things. Now the proof. If you have any construction, you'll have to write the construction. So that's the order. Given, to prove that, construction, and proof. This is the order. You'll have to first write what is given, then what is to be proved, construction if any, and then the proof. This is the order. So here we don't need any construction. So given, to prove that, and the proof. Now in the proof, mention the two triangles first. Which are the two triangles? Are you all listening, children? Whenever you learn it in school, I'm nervous to teach because not nervous exactly. Meaning somehow I can't keep my spirits high because I always feel that I'm telling you something which you already know. Are you all listening to me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Please, children, stay focused. Maybe it's, if you know it very well, you're revising now. Yeah, so first you'll have to mention the two triangles. You'll have to mention the two triangles. Which are the two triangles you have to prove are congruent, this one and this one. So write their names. Any order you can write the names. See, once you prove that they are congruent, the order is very important. We'll come to that. But here, when you write here, you can just name the triangles. Anyway, you just name it. You can call it AOD or, ADO, whatever. Any order you can name the triangles here. You can call it BCO, OCB, whatever. Okay, mention the two triangles in this triangle and this triangle. Now write out the equal, that is the pairs of equal sides or equal angles, whatever is known or whatever you have found. Whatever is known or whatever you have found. Now, before you write, you must gauge what rule you're going to use. So here, because we know about one pair of sides, two pairs of sides, and one pair of equal angles, so it is essays. You know what is SAS. So I always write in that order. See here, SAS. I always see, I write it in that order, but that's not important. You can write it in any order. But mostly, such proofs, it's not a numerical situation to start working. You will always observe the figure, understand what is given, and then you will figure out what a rule to use. And then only you'll start working. You will first figure out what rule to use, and then you will start working. So when you look at this information, you will make out it is SAS. So you list the equalities in that order, SAS. So see here, I've written, now how do you write? All this is about, that is all the information to the left side of the equal to sign, all this is about the first triangle. And all this information is about the second triangle. Always write like that. You have mentioned the two triangles, right? So in whatever order you have mentioned the two triangles, maintain the same order. So first triangle, second triangle. So here, this is of the first triangle, this is of the second triangle. This is of the first triangle. Okay, this is the side of the first triangle. This is the side of the second triangle. This is the side of the first triangle. This is an angle of this. This is an angle of the first triangle. This is an angle of the second triangle. This is the side of the first triangle, side of the second triangle. Always like that. So all this is about the first triangle. All this is about the second triangle. Which is the first triangle? This one. Second triangle, this one. So you cannot write like this. Two sides which are equal. See, now if I write, supposing I write AO is equal to DO. AO is equal to DO. That's not a valid information. Simply writing something is equal to something is not a valid information. You must write one side of the first triangle is equal to one side of the second triangle. Simply writing something is equal to something, some three things equal is not congruency. You cannot establish congruency like that. It's not just writing some three things which are equal. It should be side of the first triangle equal to the side of the second triangle. One angle of the first triangle equal to an angle of the second triangle. So if you write, supposing, supposing these two angles are equal. These two angles are of the same triangle BOC. You cannot write angle 1 is equal to angle 2. Okay, I've written some equality. No, this is not valid. Angle 1 is equal to angle 2. This is not valid because both the angles are of the same triangle. It's not a valid information. That information can be true, but to prove that will not help you. That is not a helpful information to show that the triangles are congruent. So OA of the first, see, when I say first triangle, this one, children, second triangle is this one. Okay, so that's how we write the information. OA of the first triangle is equal to OB of the second triangle. I am not writing that, it's given. See here, OA of the first triangle is equal to OB of the second triangle. That's given. Then angle AOB, AOD, this is AOD of the first triangle is equal to angle BOC of the second triangle because they are vertically opposite angles. And then OD of the first triangle is equal to the side OC of the second triangle because it's given. It's given. So now we have written three pairs of equalities. And that goes with SAS, congruence rule. Side, angle, side. Two sides and included angle. I told you why included angle. Because when, okay, now look at the information. Look at this information of one triangle. OA, OD, and this angle. So for this angle, these are the arms. That's why include angle. Here, for this angle, you can see here, for this angle, OB and OC are the arms. OB and OC are the arms. That's why include angle. Okay, so that makes SAS rule. All right, children. So by SAS, no, I think you need to excuse me. I'll just have some water and come back. Please write down, children. I'm just coming. Don't waste your time. Yes, children. Yeah. So after listing the equalities like this, I told you, you must first decide the congruence rule and then write the equalities in the correct order. SAS I've written. You can write this also first. You can write this as first and then this one. That's fine. You can switch the first and third information. Okay. So then the next step is to write, say that they are congruent. Therefore, this triangle is congruent to this triangle by the SAS congruence criterion. Now, the order is very important. The order in which you name the triangles is very important. Here, this order is not important. But when you use the congruency symbol, then the order is very important here. Now, what is the order? Now, if you say triangle, if you call this triangle, see, you can call this triangle in different ways. You can call it triangle AOD, you can call it ODA, you can call it DAO, you can call it in different ways. So, if you name this triangle AOD, 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 see here, AOD like this. Now, when you say A over here, it is B over here, right? See, I always say that, the direction in which you move. See, from AO, you're going to OD. So move correspondingly here. From BO, you'll have to go to OC. So if you say AOD here, you must say BOC here. Here. If you say AOD, you must say BOC. I can tell you in a different way also. That's one way. If you traveling in, the direction in which you travel, if you say like AOD here, you must say BOC here because AO is equal to BO. So AOD, BOC. Okay. Otherwise, what you can do is, see here. Now you have this OA is equal to OB, right? OA is equal to OB, this information. Then here you have OD is equal to OC, OD is equal to OC. OD is equal to OC. Just write this one as AO is equal to BO, and write the other one as like this. So AOD, AOD, BOOC, BOC. So AOD is congruent to BOC. Nothing, there is no, simply just remembering in some way, that's all. I'll tell you again, OA is equal to OB is one information and OD is equal to OC is the other one. See here, these two. If you can't make out what is the order, how do I name the triangles? So what you do, my God, my throat, shit. Okay, so I'm saying now the common letter is O, right? The common letter is O. You just write OA as AO. It's the same. And you write OB as BO. It's the same. OA, AO. OB, BO, both are the same. Write the other one as it is. OD is equal to OC as it is. Now you can see here AO, OD. AOD. BO, OC. BOC. BOC. O is repeated, no? So AOD, BOC. That's all. That's the order. You can call it in different ways. You can call it, you can even say DOA. If you say DOA, okay, tell me now. I'll tell you one, you tell me for the others. If I say triangle DOA is congruent to triangle, if I say DOA, I must say COB. If I say DOA, then I must call this triangle COB. COB. Now tell me, if I write triangle OAD, I'll clear the screen. If I write triangle OAD, then is congruent to what triangle?
OBC.
OBC. If I say OAD, you must say OBC. So you cannot write. Okay, now if I say triangle ODA is congruent to triangle
OCB. OCB.
OCB. So the order will keep changing. So you should be very careful with the order. If you say ODA, because see here, OD is equal to OC. See here, OD is equal to OC. Yeah, correct. OD is equal to OC. Then DA is equal to CB. DA will be equal to CB. That is a new result. Then OA is equal to OB. Yeah, OA is equal to OB. All that equalities must be in the correct place. The equalities must be in the correct place. So now see here, when you write it like this, AO is equal to BO. 1 minute. AO is equal to BO. See here? Yeah, correct. AO is equal to BO. Correct. Then OD is equal to OC. Yeah, OD is equal to OC. Correct. Then the new result is AD is equal to BC. Yeah, AD is equal to BC is not given, but that is a new result. Now that we have proved the triangle is congruent, we say that AD is equal to BC, CP, CT. That means corresponding parts of congruent triangles. Corresponding parts of congruent triangles. When two triangles are congruent, their corresponding parts will be equal. When two triangles are congruent, once you prove that the two triangles are congruent, their corresponding parts will be equal. So we say CP corresponding parts of congruent triangles are congruent. Are congruent, meaning are equal. Congruent means equal. Corresponding parts. Parts meaning sides or angles. What are the parts of a triangle? Sides or angles? What are the parts of a triangle? Sides, angles, that's all. So when we say corresponding parts, they can be corresponding sides or corresponding angles. Not that parallel lines, transversal corresponding angles, not that corresponding. Don't get confused, not the alternate corresponding angles. So when we say corresponding parts, parts are angles and sides. So it can be corresponding angles or corresponding sides. So corresponding parts of congruent triangles are congruent, are equal. So once you prove that the two triangles are congruent to each other, we have some results that will follow through CPCT. CPCT, because the triangles are now identical, their remaining corresponding parts are also equal. Okay, so now from this congruency, you can say that this side is equal to this side, because now they're congruent. So this is the third pair of sides. They'll also be equal because they're identical triangles. So the third pair of sides also will be equal now. Anyways, we are not asked to say that, so we'll not mention. So we have to prove that the two triangles are congruent. Okay, done. We prove that they're congruent by the SAS congruence rule. Now you'll have to show, we're done with this. This is over. Next what? We'll have to show that AD is parallel to BC. How do you show that two lines are parallel to each other? their corresponding angles must if a pair of corresponding angles are equal, or if a pair of alternate angles are equal, or if a pair of co-interior angles are supplementary, then the lines are parallel. So you need to find two angles that are equal. They can be corresponding or alternate angles. They must be equal. So if they're equal, then you can say that the lines are parallel. So you should show that AD is parallel to BC. Always remember, if you have to show that two lines are parallel, you must prove that corresponding angles are equal, or alternate angles are equal, or co-interior angles are supplementary. Only in these only in one of these three ways you can show that the lines are parallel to each other. So you will have to show that AD is parallel to BC. AD is this one is parallel to BC. So see here, this line transversal, this line. You will have to show that these two lines are parallel. So you should show that these two angles are equal. You will have to show that this line BC is parallel to AD. This one. This is AD. This is BC. You must show that they are parallel. That means you must show that this angle is equal to this angle. So if you show that this angle is equal to this angle, you can say that they are a pair of alternate angles and they're equal. So the lines are parallel. So you have to write, or you can even take this transversal. BC parallel line, this is the transversal AD. Not parallel line, I should say line. See here, this is line BC, transversal line AD or line segment AD. So then you should show that these two angles are equal. Alternate angles are equal, so the lines are parallel to each other. So I have taken up OAD. Okay, I have taken up this one. So I have used this part like this. So I must say that this angle is equal to this angle. Now that the two triangles are congruent, their corresponding angles will be equal. So this angle of the first triangle is equal to this angle of the second triangle, CPCT. How do you know that? See here, OAD, OAD of the first triangle is equal to OBC of the second triangle. How do you know that? See here, go back here. Angle A is equal to angle B. See here, children. Angle A of the first triangle is equal to angle B of the second triangle. Angle A of the first triangle is equal to angle B of the second triangle. O of the first triangle is equal to O of the second triangle. They're congruent, no? So O of the first triangle is equal to O of the second triangle. This is O in the first triangle. This is O in the second triangle. They are equal. Then D of the first triangle is equal. Angle D of the first triangle is equal to angle C of the second triangle. This is angle D of the first triangle. It's equal to angle C of the second triangle. The corresponding angles are equal. Some you will know, which you don't know, now you can say through CPCT. If you already knew that, that's different. If you didn't know some information, now you can get it. If you didn't know some equality, now you can get it through CPCT. Angle A is equal to angle B. Angle O is equal to angle O. Angle D is equal to angle C. AO, side AO is equal to side BO. Side OD is equal to side OC. Side AD is equal to side BC. Now you write whichever you want. Now you have to prove that the lines are parallel. So you're taking up this portion. You say that this angle is equal to this angle. This angle, that is OAD, is equal to this angle, that is OBC. Why? CPCT. Simply I'm not writing that. See here, angle A is equal to angle B, first position, AB, first position. Angle A is equal to angle B, CPCT. But angle OAD and angle OBC are a pair of alternate angles made by the transversal AB with the lines AD and BC, and they're equal, and the alternate angles are equal. How are the alternate angles equal? Because they are the corresponding parts of the congruent triangles. See, I'm not saying they're equal because they're alternate angles. Don't get confused, children. I'm not writing that these two angles are equal because they are alternate angles. How can we say they are alternate angles? They are alternate angles, but how can you say that they're equal? Because they're alternate. Because the lines are not parallel. They are equal because they are the corresponding angles of congruent triangles. Those two angles are equal because these two angles are equal because They are the corresponding angles of the congruent triangles. So they are equal. But they are also alternate angles. Made by the transversal AB with the lines AD and BC, and the alternate angles are equal. So AD is parallel to BC. Yes, children, now you must tell me if you understood the rule, SAS rule.
Yes, ma'am, it's clear.
Yes, ma'am, understood.
All right. Have you finished writing, children?
It's completed, ma'am.
Yes, ma'am.
All of you?
Completed, ma'am.
All right. Okay. So here in this figure, AB is a line segment. See the figure as I'm reading. AB is a line segment, okay? And line L is its perpendicular bisector. Line L is its perpendicular bisector. So L is L is perpendicular to AB. L also bisects AB. Children, I'll be doing the extra proofs also in the middle, like because some this class no, but from the next class onwards, maybe we'll do some 3-4 proofs from NCRT and 2 sums outside NCRT. So just for your information, yeah. Yeah, so AB is a line segment and L is its perpendicular bisector. L is perpendicular to AB. L is perpendicular to AB and L bisects AB. These are two different things. L is perpendicular to AB, meaning 90 degrees. L is perpendicular to AB. L bisects AB. That means L cuts AB into 2 equal halves. AC is equal to BC. So perpendicular bisector conveys 2 things. Gives 2 Perpendicular bisector conveys 2 information. Perpendicular bisector. L is perpendicular to AB. That means it makes 90 degrees with AB. And L bisects AB. That means L cuts AB into 2 equal pieces. AC is equal to BC. AC, that is the line segment AC is equal to the line segment BC. C is the midpoint of AB. C is the midpoint of AB. So much we have from this. AB is a line segment, L is the perpendicular bisector. If P lies on L, okay, so P, there's a point P. It lies on L, yeah. Show that P is equidistant from A and B. That means you must show that PA is equal to PB. P is equidistant from A and B, meaning you should show that PA is equal to PB. P is at equal distances from A and B. You must show that P is at equal distances from A and B. That is PA is equal to PB. See, so whenever you have to, show that 2 sides are equal, just show that the I'm sorry, you see PA will be of one triangle, PB will be of another triangle. PA will be the side of one triangle. PB will be the side of another triangle. So show that those 2 triangles are congruent. Once you show that those 2 triangles are congruent, their corresponding sides and corresponding angles will be equal. So that way you can show that PA is equal to PB. You must not, if PA and PB are the sides of the same triangle, then you cannot. You have to show that PA is equal to PB because P is equidistant from A and B. All right. So take up a triangle which has PA as a side. Take up another triangle which has PB as a side. Show that these 2 triangles are congruent. Then these will be the corresponding sides. So they'll also be equal. Such a simple one it is. So take up these 2 triangles because let me call this the first triangle. This one, children. This is the first triangle. And this one is a second triangle. This one is a second triangle. So the first triangle has PA in it, and the second triangle has PB in it. The first triangle has PA, the second triangle has PB. Okay, so the first triangle is PAC, the second one is PBC. PAC, PBC. Okay, now we'll have to list the information. AC of the first triangle, AC is the side of the first triangle, is equal to the side BC of the second triangle. Why? Because it's given, no, bisects, L bisects AB. So we know that AC is equal to BC. So AC of the first side, AC of the first triangle is equal to the side BC of the second triangle. Next, this angle is equal to this angle. This angle of the first triangle, this is an angle of the first triangle. This is an angle of the second triangle. And both equal to 90 degrees because perpendicular is given. That's a second, that is the second equality. Then PC is equal to PC common side. Because PC is the side of both the triangles. So it will be equal. PC is equal to PC. PC is a side of the first triangle. PC is also a side of the second triangle. PC is a side of the first triangle. PC is also a side of the second triangle. So PC is equal to PC. So what we have written, one pair of equal sides, one pair of equal angles, another pair of equal sides. SAS. SAS. Why SAS? Look at the angle. Look at the angle. We have mentioned about this angle and this angle. Which are the arms of this angle? This side and this side. Which are the arms of this angle? This side and this side. So that's what we have mentioned. We have mentioned about this side and this side, and these angles. So by SAS congruence criterion, the two triangles are congruent to each other. Now that they are congruent, PA is equal to PB, CP, CTC. So let me tell you how to name the triangles in the correct order, children. So you have written AC is equal to BC. AC, see this information, AC is equal to BC. And you have written PC is equal to PC. Write PC as CP is equal to CP. PC, CP. So see here, ACP, AC, CP, ACP. BC, CP, BCP. No, from the way I'm saying, you should understand. I'm not explaining. From the way I say, you should understand. See, the first information is AC is equal to BC. And that C is again there in the second information. So write that first. CP is equal to CP. See here, AC, CP, BC, CP. So ACP, BCP. ACP congruent to BCP. That's the order. That is the order. And now you can see here, AP, side AP is equal to the side BP. See the position. The side AP is equal to the side BP. CPCT. AP is equal to BP, CPCT. Because the two triangles are congruent. You have proved that they are identical. That means their corresponding sides, now their corresponding sides and corresponding angles must be equal. So AP is equal to BP, CPCT. So if AP is equal to BP, that means P is equidistant from A and B. Please write down, children. Done, children? Please let me know if you finished writing.
Ma'am, I'm still writing.
Okay.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right. Who's not learned this chapter? Who in the meeting has not? Yeah. Who in the meeting has not learned this chapter at school so far? Netra. Netra, is it clear to you, Netra? Any questions?
No, ma'am. Yes.
All right. Yeah. So see this. Line segment AB is parallel to another line segment CD. Okay, so AB is parallel to CD. Fine. O is the midpoint of AD. Okay. O is the midpoint of AD. O is not the midpoint of BC. That's not given. O is the midpoint of AD. Now, we should not assume that O is also the midpoint of BC. That's not given. So O is the midpoint of AD means AO is equal to DO. O is the midpoint of AD. That means AO is equal to DO. Okay. So parallel is given and you can see it's marked. AO is equal to DO. You can see it's marked. Show that these two triangles, this one, triangle 1 is congruent to triangle 2. Let's do that first. We should show that triangle 1 is congruent to triangle 2. You can see the name here, AOB and DOC. Okay. So to prove that these two triangles are congruent, again, we need to list any three pairs of equalities which suits any one of the 5 congruence rules based on the information given. Now you see, you cannot select, okay, let me use SSS. No, it's not like that. You cannot choose one of the 5. Depending on the information given, depending on the information, you should select the correct identity. Oh, sorry, not identity, sorry. Depending on information given, you'll have to select the correct congruence rule. You cannot select the rule first. Okay, let me use ASA for this. No, it's not like that. Depending on the information given, based on this, you should use that relevant rule, congruence rule. Sometimes more information is given, then you can use more than one rule. Okay, sometimes you'll have more information. So then you can use this or that, anything you can use. But when you have just sufficient information, then you can use only one particular rule. You cannot choose anything from the 5. Only one among the 5 will be suitable for the given information. Okay. Yeah. So again, what to write about the two triangles? In the first triangle, in the two triangles, OA of the side OA. See, when you say triangles, either you will say side or angle, nothing else you have. So side OA of the first triangle is equal to the side DO of the second triangle. See, you can write AO, DO, AO, OA, both are the same. DO, OD, both are the same. Don't Don't think if you write AO, you must write DO, nothing like that. OA or AO, both are the same. It's the same line segment. When you say line segment AB or line segment BA, both are the same. Okay, so side AO of the first triangle is equal to side DO of the second triangle given. Then vertically opposite angle. See here, this angle of the first triangle is equal to this angle of the second triangle. Vertically opposite angles are equal. Then this angle of the first triangle is equal to this angle of the second triangle because parallel line, transversal, parallel line. Alternate interior angles are equal. Alternate interior angles are equal. Listen to me. Listen to me. Let's write out all that is available. We need to write only 3, but we'll write whatever is there. So now see, we have this angle equal to this angle. We have angle 1 is equal to angle 2. Vertically opposite angles are equal. We have angle 3 is equal to angle 4. Alternate angles are equal because we have parallel lines here. AB is parallel to CD. So alternate angles are equal. And we also have angle 5 is equal to angle 6. Again, alternate angles are equal. Now you write whichever you write any 3 equalities, but that should suit a congruence rule. So now supposing you write, see, this is all you have, children. You don't have anything more than this. See, now you cannot write OB is equal to OC. You cannot say OB of the first triangle is equal to OC of the second triangle. That's not given. That's not given. You cannot write 2 sides and put an equal to sign in the middle. No, it should be given. Or you should be able to give a reason for that. Simply, we cannot write 2 sides and say they're equal. Okay, so this is all we have. Now you cannot write AB is equal to CD. You cannot write AB of the first triangle is equal to CD of the second triangle. You cannot write that. It's not given. Nor can you justify that. So this is all you have. This is all you have. So now supposing I write, see the 2 triangles. Please watch. AOB is one triangle. COD is the other triangle. Okay. Now supposing I write angle 5 is equal to angle 6. Okay. Alternate angles are equal. Then I write OA of the first triangle is equal to OD of the second triangle. Then suppose I write, what do I write? Angle 1. Angle 1 of the first triangle is equal to angle 2 of the second triangle. Okay, so what have I written? What have I written? I've written about, sorry, my throat is really troubling me today. Sorry, I'll just come. Yeah, children. So based on the information we have written, we've written angle 5 is equal to angle 6. And then OA is equal to, see, all this is of the first triangle, AOB. And all this is of the second triangle, COD. Okay, now what have we written?
Ma'am, it's ASA congruence criterion.
1 minute. Yeah. So it's about this angle. See, I've marked angle 5, angle 1, and this side, OA. And in the other triangle, it's about angle 2, this angle 2, angle 6, and OD. So why do we say that this is 2 sides and, 1 angle and 2 angles and 1 side? That is 2 angles and the included side, ASA. ASA. Why do we say that? Two angles in the included side. Because we have mentioned about this angle, and see, this is the side contained by these two angles. This is the side contained by these two angles. See here, this side contains these two angles. This side contains these two angles. See, when I say this side, it contains this angle and this angle. This side contains this angle and this angle. This side contains this angle and this angle. So clearly, see here, the side is OA. The side is OA. The angles contained by this side are this angle and this angle. See here, angle I erased it. Sorry, 5 and 1. They are these two angles. And the other side is OD in the other triangle. And we have mentioned about this angle and this angle. And these are the angles included by this side. So this makes ASA, two angles and the included side. Two angles and the included side. The two triangles are congruent to each other. Now, how will you name it? See, if you say AOB, you must say, because angle A goes with this angle. So if you say triangle AOB, you must say triangle DOC. You must say triangle DOC. I'll make it more clear in the next slide. So children, now you can also mention about this angle. See, angle 1 is equal to angle 2, alternate angles. Angle 3 is equal to angle 4, again alternate angles. And then if you say OA, this one is equal to OD. These are two different angles. Because the side OA, okay, talking about this one, the side OA contains angle 1 but not 3. The side OA, see, supposing you list these three information. Which three information? Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. OA is equal to OD. Supposing you list these three information. Now the side is OA. OA contains this angle and this angle. But you have not mentioned about this angle. You have mentioned about some other angle 3. So it's not 3 is not the included angle. Similarly, the other side, that is a side in the other triangle is OD. OD has this angle and this angle. But you have mentioned about angle 2. But 4 is not a part of the angles on the side OD. So in this case, we say two angles and some other side. Two angles and some other side. AAS. Because for angle 2 and angle 4, the included side is CD. For angle 2 and angle 4, the included side is CD. For angle 1 and angle 3, the included side is AB. Now you have mentioned 1 is equal to 2, 3 is equal to 4. Then if it is the included side, you should mention AB is equal to CD, but you have not written that. It's not given. We have written some other side. Two angles and some other side. We have not written the included side. If you write angle 1 of the first triangle is equal to 2 of the second triangle, angle 3 of the first triangle is equal to angle 4 of the second triangle. For angle 1 and angle 3, AB is the included side. For angle 2 and angle 4, CD is the included side. But we have not written AB is equal to CD because we don't know. It's not given that AB is equal to CD. What do we know? We know that AO is equal to OD. AO of the first triangle is equal to OD of the second triangle. We know this. We have written this one. This is not the included side. So this is AAS. Two angles and some other side, not the included side, some other side. So for the same, proof, you can use two different rules. You can use ASA or AAS depending on the information you list. Yeah. So I've used ASA. Please write down this. Children, I think it's time. So please take a screenshot. We'll continue in the next class. Children, please take a screenshot. We'll continue in the next class, children. It's time.
Taken.
Yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Yeah, thank you.
Thank you, ma'am.
Thank you. Thank you, Sanjay and Sindhu.